Quantum mechanics is the study of elementary particles at the nanoscopic level and analyzing their unusual behavior.
Consider this to be an atom, this to be the nucleus which has the proton and the neutron, and finally these to be things inside the proton and the neutron, which I'm going to reveal soon. Now, many of you might be knowing what's inside an atom: an electron, a proton, and a neutron. But what's inside a proton and a neutron? It's these quarks, which are joined together by gluons, which produce strong nuclear force for joining them. Gluons also join the proton and the neutron. Now let's know about the standard model of elementary particles. It tries to describe the behavior of matter particles and the different forces of nature with an exception of gravity. There are two types, fermions and bosons. Fermions are further divided into two types, quarks and leptons. There are 6 types of quarks: up, down, charm, strange, top and bottom. There are 6 types of leptons as well: electron, muon, tau, electron neutrino, muon neutrino and tau neutrino. Now, there are 5 types of bosons. Gluons, as we have already discussed before, are responsible for binding protons and neutrons. They produce the strong nuclear force. Then there are W and Z, which produce the weak nuclear force. There is Y, which produces the electromagnetic force. They are called photons. They also give light. Now there is an hypothetical particle, which is graviton, which produces gravity. Now there is Higgs boson as well, which was discovered recently by Peter Higgs. Higgs boson produces Higgs field. The matter particles react with this Higgs field and generates mass. Young's double slit experiment. If we take marbles, bits of matter, and shoot them through a single slit, we'd observe a single line at the back highlighting the path they took through the single slit. But with 2 slits, we'd observe 2 lines. Now with waves, we see that the waves hit the slit and radiate out, striking the screen with most intensity in line with the single slit. But with 2 slits, we see something else. If top of a wave meets the bottom of the other, they cancel each other out, and hence we see an interference pattern on the screen. So you can see the interference pattern as parallel lines. Now let's go quantum to see what happens on tiny bits of matter. Electrons are very tiny bits of matter. Now let's see what happens. When we shoot electrons through a single slit, we see a single line. So far, so good. But with 2 slits, we see an interference pattern. What? This is something else. So does this mean that matter acts both as particle and waves? Erwin Schrödinger came up with an equation for the electron's wave function. Using this equation, we can find out the probability of an electron being in a particular position. Think of the wave as a pack or a bundle of probabilities. Size of the wave at any location predicts the likelihood of the electron to be there. It seems as if the electron is not in a fixed position, but there is a probability of an electron in being at many places at once. Schrödinger's cat and the law of superposition. Schrödinger's cat is a thought experiment designed to show the law of superposition. According to this, if we keep a cat and a radioactive element and seal the box, then there's a 50-50 chance that the cat is alive or dead. So we say that it's both alive and dead, so both the cases are in superposition. But as soon as box is opened, we see that the cat is either dead or alive, so we say that the superposition has been collapsed by the act of measurement or observation.